Hi, my name is Todd Huber, and I'm here today to talk to you guys about the civil engineering marvel that is Machu Picchu. Now, some areas for improvement today were the lack of visual assistance in my PowerPoints, i.e. pictures. So I added some helpful pictures that will hopefully help me demonstrate throughout the presentation different significances of the water system and the construction process. And then also, my goal is to not read as much straight from the PowerPoints, so then it doesn't just feel like I'm reiterating what I already wrote down. So let's get started. Some goals of this presentation. I wanted to show the thought and the effort that was put in to the city's preparation, and to also just demonstrate the significance of Machu Picchu as a historical site through their impressive water system and construction process. Now, some of the prep work. The land originally was uninhabitable due to the sheer cliffs and poor water runoff, which led to a high danger of landslides. So terraces, to mitigate this problem, terraces were built into these cliffs to add more land cover and to also help prevent these landslides. Now, the water system for the residents, the closest natural spring was 749 meters away, so a canal had to be built connecting that spring to the urban sector. Now, this canal was built with such efficiency that it could hold over 300 liters a minute, which was over double what the natural spring supplied. Now, this spring would supply this canal, and the canal would then run into 16 fountains in the urban sector, which you can see on the right is one of them. Now, in order for the water to come out the spout, and instead of just running down the wall, a flow rate of 10 liters a minute had to be provided, which the canal usually provided more than. Now, the runoff prevention water system is actually a huge essential to the longevity of this site. When inhabited, Machu Picchu received an average of 1,940 millimeters of rainfall per year. Now, all this land had to go somewhere. In order to maximize the above ground, or no, the groundwater runoff, a thick 1 meter layer of recycled rock chips were laid in order to allow the water to drain through the soil, then through these rock chips into the groundwater table and then out that way. Another way was to maximize overland flow. And to do that, 129 storm drains were built in the urban sector in order to move all the excess water out of the city into the main drain, which eventually drained off the mountain. Now, the building foundations, small rocks were usually laid at the bottom in order to cause a flat foundation and to provide stability. And they chose granite stone due to its material properties, i.e. its strength and its longevity. Now, one bad thing about granite stone is that it was quite heavy, heavier than wood, which was another possible building material that they could have used and opted not to. So in order to move these heavy stones, inclined planes were built to move these uphill and downhill from the quarry to their actual building site. Now, when built, the wall was usually at least 0.8 meters wide when it reached ground level. And then from ground level, they would use a type of lever system to move the rocks up and to put them in their correct place on the wall. Now, in order for these stones to stay in place, two different techniques were used. One was, of course, mortar, which was used a lot in that period. And that was just a mixture of clay, and they put that between each stone in order for them to stick together. And another one, less used, was dry ashlar. And this is what the Inca engineers were known for. They would cut out these stones in order to fit in their very particular places on that wall, and did not require any type of mortar for them to stay in place. As you can see on this picture to the right, it was very impressive. It almost looks like a jigsaw puzzle. Now, the engineering disciplines covered in this presentation were civil engineering, city planning, environmental engineering for water systems, and the structural engineering for the actual construction of the buildings. Some acknowledgement, special thanks to Jenny Rutherford, Gail Powell, and Crystal Wyckoff for their helpful revision and feedback. Thank you, and have a great day.